Now let us proceed towards the next coordinate system. As I already told you that a different coordinate system is needed whenever the problem is drastically changed. For example, in the rectangular coordinate system will not be very helpful if we have a problem like this. Let's say we have a watch with our hand, and for simplicity let us just consider only one hand, one time telling hand. So if there is a problem that tells us to find out the locus of this hand which is moving clockwise, so what will happen that this hand at every point of time it will change its position taking a reference of the center, because it is moving radially, means this hand is radial and it is moving circularly, so the locus will also change circularly. So at any point of time telling its position in x, y and z coordinate system, it is very difficult, because every time it changes its position, at least x and y will change drastically. We need some other coordinate system to locate this kind of thing. So there is something known as cylindrical coordinate system that comes to help in this case. In cylindrical coordinate system, the basic shape that we imagine, that we consider, is a cylinder, as the name suggests. So if you imagine that there is a cylinder, and for simplicity, even in the previous coordinate system, what we did, that we did not consider all the portions of a shape. In cuboid or cube also, we only considered the first positive quadrant, that is in x, y, z. So what we are doing, that we are slicing this cylinder in 4 parts, and we are considering only 1/4 part of this cylinder, and anything that we do in this part of the cylinder, this section of the cylinder, this is that section of the cylinder, that will help us in understanding all the rest of the coordinates, what is happening with this coordinate system. For example, in the cylindrical coordinate system, if we want to locate a point, we have to understand that in a cylindrical coordinate system, what are the dimensions that are present to make a cylinder. Our reference will always be x, y and z, but in cylindrical coordinate system, what we consider is, the first thing is the radius, and this radius is denoted by rho. This radius to make a cylinder will always be perpendicular from the z-axis. Why? Because to make a cylinder we have two circles, one is top circle and one is bottom circle, and these two circles are connected with a curved surface. To make these two cylinders of the same radius, they should be having a common axis in the center. So a cylinder, because it has a common axis at the center, it will have a common radius throughout its height, and that radius is denoted by this symbol rho. Okay, so this rho will help us in making two circles, the top circle and the bottom circle. But to make a circle we need rotation, right? We need rotation either counterclockwise or clockwise. So this rotation is taken care of by this phi angle. This phi angle starts from x-axis, positive x-axis, and it reaches again this x-axis traveling 2 pi angle. It starts from 0 and goes till 2 pi, that means 360 degrees. That is why it will complete the full circle and make a complete radius. And the last thing that is left is to connect the top surface, top circle and the bottom circle, we need some vertical length. This vertical length is denoted by this z coordinate. So rather than having a point P and representing it with P, X, Y, Z, this time we have another P which is denoted and located by 3 different points, 3 different dimensions, that is rho, phi and z. So we should remember In a cylindrical coordinate system, why we are representing things with rho phi z? Because the shape is like that, because the reference shape is a cylinder. So we need these 3 points to locate anything inside or on the surface of the cylinder. So we should remember that. And in my next video, I will definitely do some interactive and very good exercise so that you can understand these coordinate system concepts very well, because they are very important, and those who don't understand this, they will have a very tough time in understanding electromagnetic theory. So I am very hopeful that you will understand. You will play this video again and again and try to understand what I am trying to explain. Let us see one more example, because having this clock's example was not enough, because a clock can be said that it only moves in the hand of the clocks only move in two dimension, right? Because it's a circle, means the clock does not move up and down, it only moves circularly in a plane. But let's say that there's a pipe. This pipe has the diameter d and the height h. So let's say that a particle is moving in this helical way, helical direction. And the helix direction is that it moves circularly, but it also displaces itself in a direction. So to locate this helical movement of some particle that we are considering, we need what? We need circular motion as well, that is denoted by phi. We need a radius also, to understand that how much is the diameter of this spiral or this helix that is being made. So we need a rho as well to find this radius. And also we know that for making a helix, we need this upward motion or this downward motion also. So we need a z as well. So in that case, when we are locating a particle which is moving from one point to another in a helical motion, we need to use this example, use this coordinate system, which is cylindrical coordinate system, and all the dimensions which are rho, phi and z will all be used. So let us see that what are all the limits that we have in rho, phi and z. So as I already told you that rho is a radius, and radius always starts from 0. A diameter is a quantity that starts from something minus infinity and go to plus infinity, but the radius always starts from the origin. That is why whenever you are encountered with a symbol that shows radius, you always have its starting point as 0, and you should remember this. But mathematics says that radius can go anywhere in positive side, so yes, it can be up to minus infinity. Then we have phi. Phi is called as azimuthal angle, and it only travel on xy plane. But we need a full circle to make a cylinder. That is why it starts from positive z axis, moves counterclockwise, and again reaches back to again this x axis. This, as I told you, right? It starts from here, goes again to the back and reaches to this x axis. So that means it moves complete 360 degree. So we have 0 to 360 degree or 2 pi. And z, this z is same as what it was in rectangular coordinate system. So it comes from minus infinity and can go to infinity, because a cylinder theoretically can be of infinite height and can be of infinite radius as well, as we can see here. So z can be from minus infinity to plus infinity, because it is the same dimension that we saw in rectangular coordinate system. So that is what cylindrical coordinate system is. I hope you understood this as well.